Today we are talking about reflections and translations of the parent functions from yesterday. So for problems 1, 2, and 3, we need to complete the square and put into vertex form. So when we're talking about quadratics, when they're mentioned vertex form is f of x equals a, x minus h squared. Let me change to red. Ran out of room. Plus k. So there's vertex form. F of x equals a, and the parentheses is x minus h, and x minus h is squared, and then we have plus k at the back. Now the first thing they want us to do is to complete the square. In order to complete the square, there's a special formula you learned back in Algebra 1 and Algebra 2, and in order to complete the square, the formula we use is b divided by 2 squared. And that's when your equation is in standard form, ax squared plus bx plus c. So to complete the square, you take the b value, which is the coefficient in front of x, divide it by 2, and square it. So b over 2 squared. Okay, so when we are going to be completing the square, we're just going to be concentrating on the first two terms. So just concentrate on the terms that contain an x. And now we need to complete the square. So using this formula down here, what is the b value for problem 1?
Negative.
And what is negative 8 divided by 2? And negative 4 squared is 16. So I need to add 16 to that expression in order to complete that square and make it a perfect square trinomial. So adding 16 makes it a perfect square trinomial. And behind that we have the plus 5. Now if I have an expression, can I just add a random number to it and it's still equivalent to what I started with? No. But if I add 0 to something, does it stay the same? Yes. So if I add 16, what would I have to add back here to make it 0? Negative 16. So whatever number you have to add the opposite so that you're actually adding 0. Because positive 16, negative 16, what am I actually adding there? 0. So that expression is still the same. Now the next thing we have to do is get it in vertex form. So to get it in vertex form, you need to factor this perfect square trinomial, and it factors easily and nicely as a binomial squared. And the shortcut to factor that is square root the first term and square root the last term. So the square root of x squared is x, square root of 16 is 4. And whatever symbol you have for the middle term, that is the symbol you need to have in the middle. So keep the sign of the middle term. So if this is a minus 8x, this needs to be a minus in the middle. Now back here, combine our constants. So what's 5 minus 16? Negative 11. And this is called vertex form because from this format I can easily find the vertex, which is hk. And to find that vertex, you take this value and change the sign. So if this is a negative 4, you change it to a positive 4. Then the k value is negative 11. So from vertex form, you can easily find the vertex quickly and fast. Okay, next one, number 2, we need to complete the square to get it into vertex form. So again, you need to just focus on the first two terms. So focus on the two terms that have an x. Now how is this one different from problem 1? Yeah, we have that 3 out front. That 3 is called our leading coefficient. So if you have a leading coefficient, you need to factor it out. So I need to factor out that 3. When I factor out the 3, what would go in those parentheses?
X squared minus 4.
X squared minus 4x. Now I need to complete the square. So use the formula down here. So when I complete the square, what is the b value? What's negative 4 divided by 2? Negative 2, what's negative 2 squared? 4. So we need to add 4 to complete that square. Now, I added 4. Actually, did I add 4 here? No, technically I didn't add 4. What did I actually add here? 12. That 3 up front, 3 times 4 is 12. So if I add 12, what do I have to do at the back? What's the opposite of add 12? Subtract 12. Now bring down the leading coefficient, so bring down the 3. And now we need to factor that perfect square trinomial. So again, you square root the first term, square root the last term.
X minus 2.
Yes, we need to have an x minus 2 inside the parentheses. And combining these two constants, what's negative 7 minus 12? Minus 19, or negative 19. So what would HK be for that one? 2 negative 19. And then the last one to complete the square is number 3. So again, when you're completing the square, just focus on the two terms that contain an x. And if it has a leading coefficient, what do we do with that leading coefficient? Factor it out. So the first step is factor out the negative 3. And what would go in the parentheses? X squared plus 6x. Now complete the square to make our perfect square trinomial. And what number would complete the square? 9. But we're not adding 9. What are we actually adding here?
Negative 21. I mean 27.
Negative 27. So if this is a negative 27, what do I have to have in the back? Add 27. So you add the opposite. So this time it was negative. So this time it's added. Yes?
Why 9?
Why 9? Because we completed the square using that formula b over 2 squared. So our b value was 6. So 6 divided by 2 is 3.
Okay.
And then 3 squared, that's where that 9 came from. So it's the same formula. So b over 2 squared. And simplifying that, we would have negative 3. What would go inside the parentheses there? X plus 3.
And minus 8.
And when you combine those, yes, it would be minus 8. So what would HK be? Negative 3, negative 8. Okay, now go into our parent functions and doing some transformations. Okay, the instructions say name the parent function and graph each function. So for number 4, what is the parent function? Absolute value. How do I know it's absolute value?
Because not the
Those vertical bars, yeah. Now, what does that negative up front make it? Well, first of all, what does the parent function look like? It makes a V shape. And what does the negative up front make it do? Reflect over the x-axis. So if the a value is negative 1, that means it will reflect over the x-axis. So if your a value is negative, it reflects over the x-axis. So instead of pointing up, it needs to point down. And for this one, what is HK? 0, 0. And we need to point it downward. Again, my rule when it comes to graphing is if the point will fit, graph it. And make sure you put arrows showing it will keep going downward. Next one, number 5. What is the parent function here? Yes, that is the square root. general equation for a square root function is f of x equals a square root of b times x minus h plus k. Now for problem number 4, when the a value is negative, it reflects over what? It reflects over the
For the y, x,
x-axis. X-axis. Now if it's the b value that's negative, then that means it will reflect over the
y.
y-axis. And let me just sketch the parent function on here. Don't put the parent function because this is not the answer. I just want you to know where we came from, where we started. So there's the square root parent function. Now every point needs to be reflected over what axis? Looking at this one, is it the a value that's negative or is it the b value that's negative? This one, the b value is negative. So if it's the b value that's negative, which axis does it reflect over?
The y.
The y-axis. So this point at 1, 1, if it's 1 to the right, what I reflected is going to be 1 to the left. So go ahead and start reflecting those points. So that first point would be at negative 1, 1. What about the origin? If the point is on the axis, can it reflect over the axis?
No.
No, so the origin stays where it's at. And then 4, 2, when I reflect it, where would it be? Negative 4, 2. And 9, 3, when I reflect it, it would be at negative 9, 3. So you really need to have a good understanding, just a mental picture in your head of what these graphs should look like. That way you can easily do these transformations. So make sure you have an arrow showing you a key pointing to the left. Next one, number 6. What's the parent function here? Cube root. What does the cube root parent function look like?
1, 1, 0, 0, 0, 1, 1.
Now let me go ahead and plot it. So we have a point at 0, 0, 1, 1, 8, 2. And then we have an arm over here. Now again, this is the parent function, so you can see what's going to happen for our transformation. Now I do see a negative. Is that the a value that's negative, or is that the b value that's negative? Yes, so here our b value is negative. So if the b value is negative, which axis does it reflect over? Y-axis. So that means this right arm, instead of being in quadrant 1, which quadrant should it be in? Quadrant 2. And this left arm, instead of being in quadrant 3, which quadrant should it be in? Quadrant 4. So let's go ahead and reflect those arms. Now again, the origin, can you reflect the point that's on the axis over it? No. So if it's on the axis, it does not move. Now, what if I had reflected it over the x-axis instead? How would that have changed? This arm, where would it go? If I reflect over the x-axis. It would go down here in quadrant 4. And this arm, which quadrant would it go?
2.
2. So what do you notice about with the cube root function? If you reflect over the x-axis or you reflect over the y-axis? Yeah, it did the same thing. We produced the same graph there. Now, number 7. What is the parent function here? Step. If you see those square brackets, that is a step function. Or on your assignment, you may also see just a single square bracket. If you see just a single square bracket, that also means a step function. It just depended on which computer I was on and which math type software I had in order to create this assignment. Okay, now, for this one, is that the A value that's negative or the B value? That is the B value that's negative. So if the B value is negative, which axis does it reflect over? The Y. Let me draw the parent function, that way we can see what's happening. Okay, so normally the step function starts at the origin, and where is the open circle? It swings to the right. So this next point swings to the right, swings to the right. But when I reflect it over the y-axis, instead of swinging to the right, if I focus on this point right here, I know this point, if I reflect it, it would be at -1, 1. And the open circle, instead of being at 2, 1, would be at -2, 1. So instead of swinging to the right, when you reflect it over the y-axis, it swings to the left. Now, still talking about this step function, we'll come back to those dialog boxes in just a moment. But what if I had the parent function for the step function, and what if I wanted to reflect it over the x-axis? So if I focus on this point right here, it's 1 above the x-axis. When I reflect it, it would go 1 below. And the open circle is 1 above the x-axis, so it would be 1 below. So what's the main distinction between reflecting it over the x-axis and what the parent function looks like? Well, the circle, it still swings to the right, correct? Yeah, but instead of stepping up, what are we doing? Stepping down. So here the slope is negative. So the open circle is still on the right. So that's just extra information to hopefully help you when you're working through the assignment. Okay, so back to these dialog boxes. And that top one is the reflections, and we already talked about these. So if it's the A value that's negative, it reflects over the x-axis. So if it's the A value that's negative, it reflects over the x-axis. But if it's the B value that's negative, it reflects over the y-axis. Now these last two you're pretty familiar with. The plus or minus k, the k will move it up or down. So if you add a number to the back of the function, it translates it up. If you subtract a number, it translates it down. Now the h value, h stands for the horizontal shift, and it's the opposite of what you would think. So if it's a positive h, it moves it to the left, and if it's a negative h, it moves it to the right. And here the A value, so if A is negative, it makes it reflect over the x-axis. But if the absolute value of A is a number larger than 1, it's going to stretch it vertically by a factor of A, so whatever the A value is. So if it's a factor of 2, if there's a 2 out front, it's going to stretch it by a factor of 2. Now if the absolute value of A is less than 1, then it's going to shrink vertically. So if it shrinks vertically, it's going to get flatter. And usually that's going to be a fractional value. So if it's a fractional absolute value for A, it's going to make it shrink. And you just multiply vertically by the value of A. And we'll have several examples where we're working through those. Number 8, what is the parent function here? Cubic. It's raised to the power of 3, so it's the cubic function. What does the cubic function look like?
It goes up and down.
Yeah, it goes up and down. The left arm points down, the right arm points up. So that's just a brief drawing for the cubic function. Now, with these graphs, if you have multiple transformations, the best thing to do is automatically locate HK. That's your starting point. So for problem 8, what is HK? 3, 1. So there's our inflection point at 3, 1. So there's our central point, 3, 1. So we took care of the 3, we took care of the 1. Now that 0.5 is going to make it shrink by a factor of 1/2. So normally from the central point, we normally go over 1, up 1. But now we just go up half of that. So half of 1 would be a half. So from our HK, we need to go over 1, up a half, and over 1, down a half. And then we normally go over 2 and up how many? 8. I need to multiply that by a half, so half of 8 would be 4. So back to HK, go over 2, up 4. Go over 2, down 4. And normally we don't go past 2, because if I take 3 and cube it, what would that be? 3 times 3 times 3. 27. And do graphs normally go up to 27? No. So we'll just leave it at those points. So this one was shrunk by a factor of 1/2. Now if that were a 2 out front, we would double all of those. So we would go over 1, up 2. Next one, number 9. What's the parent function here?
Rational.
Rational. Now, if you have a negative in front of the x and you don't have parentheses, you need to make sure you have parentheses. So we have our x minus h. So go ahead and factor out that negative in front of the x. So inside the parentheses, I need to have x minus h. So when I factor out the negative 1, what goes in the parentheses? X plus 1. And then for the k value, it's positive 2. So get it in vertex form by factoring out the negative. And once you have it in vertex form, well, actually, we're not going to have HK because this one's one of our crazy ones because of the asymptote. But we'll still use HK so we know which way to move the asymptote. So what does this plus 1 make our asymptote do?
Move to the left 1.
Move to the left 1. So that vertical asymptote needs to move to the left 1 unit. The plus 2 at the back moves our asymptote which way? Up 2 units. So left 1 and up, and up 2, not 1. Now normally with rational functions we go over 1, up 1, and here would be curve 1. Don't draw these curves yet because we'll have to do some reflecting. So that's typically where we see this with the parents. But we have this negative, so we have to decide, is that a negative A value or a negative B value?
Negative A.
Yeah, it is. Is it out in front of the fraction? Yeah, so this is technically a B value. So here, the B value is negative 1, because this is with the x minus h. If it's with the x minus h, it's the B value. So if it's the B value, that means it reflects over which axis?
Y.
The y-axis. So this curve, when I reflect it over the y-axis, where would it go? Yeah, it would go on the left side over here. And this curve, when I reflect it over the y-axis, which quadrant would it mainly be in?
4.
Quadrant 4. Now that's reflecting it over the y-axis. But what would happen if I reflected it over the x-axis? This curve would go to which quadrant?
The 4.
Quadrant 4, and this curve would go to quadrant 2. Yeah, I would get the same graph. So let me erase things. So our curves do not go in quadrants 1 and 3. They need to be mainly in quadrants 2 and 4. I'm putting them right in the same place. Okay, next problem. What's the parent function here? Step function. So again, on your assignment, if you just see a single square bracket, it still means the step function. So again, if you have a negative in front of the x, go ahead and factor that out. And when I factor out that negative, what would go in the parentheses?
X minus 2.
X minus 2. And then we'll have the plus 4. And for the step function, you really need to know where do you start. And you do need to find HK so you can find your starting point. So what's HK here?
2 and 4.
4. So I need to start the sun at 2, 4. Now normally it swings to the right. But if it's the B value that's negative, which way does it swing? To the left. When you reflect it over the y-axis, they swing to the left. So you need to have an open circle at 1, 4. So if it reflects over the y-axis, it swings to the left. Now this one is being stretched by a factor of 2. So normally, how many units do we go up to make our next step? 1, but it's being stretched by a factor of 2. So instead of going up 1 unit, we need to go up 2 units. So go up 2 units, swing to the left. Go up 2 units, swing to the left. And fill up your graph completely. So for the step function, the A value just tells you how many units to go up to make the next step. So if there were a 3 out front, how many units would you go up? 3. Number 11, what is the parent function here? Quadratic. And the highest degree is to the second power. It's quadratic. Now, in order to graph these, we need to have them in vertex form. Is that in vertex form? Can I see HK?
No.
No. So if it's not in vertex form, you have to complete the square to get it to vertex form. So that's why we did problems 1, 2, and 3 at the very beginning, is so that we can get these quadratics into vertex form. So just concentrate on the first 2. So here we don't have a constant being thrown in here. But I do have to factor factor out that leading coefficient. So factor out the -2, and what would go in the parentheses?
X squared plus 8, I mean 4,
X squared plus
4x,
4x.
4x.
Now complete the square, so this would be -2. We'll have our x squared plus 4x. And what number will we have to add to complete that square? Plus 4. Well, am I actually adding 4 here?
No.
No. What number is this that I'm actually adding?
Well, negative.
That's -8, so what do I have to have at the back?
Plus
Plus 8. So if I have -8, I need to have plus 8 at the back. Now get it in vertex form, so we'll have -2. Factor that perfect square. And what goes in the parentheses? X plus 2. And then we have our plus 8 at the back. Now we can graph this easily with HK. -2/8. So -2/8 is our starting point. And will this parabola open upward or downward? Downward. But instead of going over 1, down 1, it's being stretched by a factor of 2. So I need to go over 1, down how many? Down 1 over 2. Sorry, over 1, down 2, over 1, down 2. And then normally we go over 2, up 4, but double 4, and what would that be? 8. So we need to go over 2, down 8, over 2, down 8. If I go over 3, what's 3 squared? 9. If I double that, that gives me 18. So over 3, down 18, puts us at the very bottom. So it moves left 2 units, up 8 units, they're reflected downwards, and it's stretched by a factor of 2. What's the parent function for number 12? Absolute value. And what does absolute value look like? A V. And for this one, again, find HK so you know where to start. What is HK? 1, 2. So start at 1, 2. And would this one point up or down?
Down.
Down. So this one's pretty basic. And number 13, what's the parent function? It's often confused with the square root. But it's not square root. What is it? Semicircle. Semicircle. That's a new one we learned yesterday. And remember the general equation is f of x equals a square root. And then we have r squared minus x minus h squared plus k. Now, again, a most common mistake is students often do think that this is a square root function. But if it were a square root function, then the x would not be squared. So if it's a square root function, it's x to the first power. The x would not have a square out behind it. And also, we have the radius squared, so we have that extra value being thrown in as well. So looking at this example, if I have a 16 right here, what would the radius be? 4. Square root of 16 is 4. And for that semicircle, we need to know where's the center. So we need to know what is HK. What is it? 2, 3. I'm going to go ahead and plot 2, 3. So there's the center of our circle. And remember, semi means what? Half. So we need to either draw the top half of the circle or the bottom half of the circle. Which one are we doing here? Yeah, if it's a plus, you're drawing the top half of the semicircle. Or the top half of the circle to make a semicircle. Now, from our centers, we need to use our radius to find the left point, the top point, and the right point. So from the center, go left 4. From the center, go up 4. And from the center, go right 4. And connect those 3 points you just made. And there's our semicircle. What is something I need to do? Yes, if I leave that center point, is it a function? No. So make sure you erase that center. So the semicircle is just that outer ring, not the central point included. Okay, then the last one. And we do have to do this one because we have an a value. So we have to see what is the a value. And what type of function is this one? Is this square root or semicircle? How do I know this one is semicircle? It has a square. So looking at that equation, what is the radius? 3. And what is HK?
5,
5, negative 6. So go ahead and plot the point, 5, negative 6. And our radius is 3. So go ahead and mark the left side and mark the right side. Now normally, that top point would be 3 above it. But we have this 2 out front. What does that 2 out front make it do? Stretch by a factor of 2. So instead of going up 3, how many do I have to go up? 6. So it's only the top number that's affected by the a value. And connect those 3 points. And there's our semicircle that's been stretched by a factor of 2. And make sure you erase those central points. Now your assignment is a worksheet, nothing from the textbook, so you don't have to have a textbook for today's assignment.